Hi everyone. Let's see how we can use Claude AI within Excel to perform Monte Carlo simulation, which is a very popular and useful risk analysis technique. In order to use Claude within Excel, we must have the Pro plan at the time of making this video. That is what is required, and Pro plan at the time of making this video costs $20 a month. And once you have the Pro plan, you can add Claude within Excel by clicking on Add-ins button under the Home tab. And once you click on Add-in, you can type in Claude within the search box. And as long as you're connected to the internet, the Claude option will show up here. You click on it and you can add. Once you add, it shows up right here. And when you click on Claude here, the first time it will ask you to log in. And once you log in the first time, you don't have to log in every time. It will show up like this. And this is where you will enter your prompts to Claude. And in the gray area right here, it will tell us what it is thinking, what it is doing. And the output will show up in the sheet itself, the Excel sheet. Now, in order to show Monte Carlo simulation example, I'll ask Claude to create an example. And then we will make Claude do a few things to perform the Monte Carlo simulation. Let's say we own a large retail store, and let's say we incur costs on 10 things. Maybe one cost component is labor cost, another one is maybe material cost, whatnot. And assume that each of these cost components change between $1,000 to $2,000 each month. Maybe cost component one is $1,200 in month one. In the second month, the same cost component could be $1,500. And similarly, all the other cost components also vary between $1,000 and $2,000. So we'll ask Claude to generate random values between 1,000 and 2,000 for the 10 components of the monthly cost. So I have this prompt already saved somewhere. So I copy pasted it here in the prompt box. And I'm saying in sheet one, create a table of two columns showing 10 monthly cost components at a major retail store, where each cost component varies randomly, equally likely, meaning any of the values between 1,000 and 2,000 have the same chance of happening. Fancy way of saying this is uniformly distributed. I'm also asking it to calculate the total cost at the bottom of the table. I mentioned it here as sheet one. If I don't do that, notice that in my sheet here, the cell that is selected by default here is G4. So it will start creating a table starting from G4. I don't want that. I want it to nicely create a table on the top left corner here. That's why I mentioned sheet one. So let's see what it does. It uses a function within Excel to generate those values. Thanks to Claude, it generates the data pretty fast. And also, it shows you the formula that it used to get these values. Notice that I didn't even ask for the cost component names, but it gave me the cost component names. It could have gone with just 1, 2, 3, 4, 5, all the way up to 10, but it gave some nice names as well. If I click on the cell for monthly cost, notice that it used a function called rand between. Rand between gives random values between the numbers that we mentioned, 1,000 and 2,000. Although rand between gives only integer values, not fractional values, which are also possible for cost components. We'll go with it right now. If I want fractional values also, then I can easily mention that here, in which case it will use some other function. For now, we'll go with it. And notice that if I, for example, press F9 key on my keyboard here, these numbers are changing. In other words, the total cost for which it used the sum function as expected is that's also continuously changing, right? So I don't have much trust in this one number for total cost and talk about it. That's why we need to do simulations of this total cost. For example, if you want to know the probability that in a given month, the total cost will not exceed, say, $14,000 or $15,000, because of this only one number, it's hard for me to be confident about whatever I'm saying about this probability that I'm interested in about the total cost. So we will ask Claude to generate another table of, let's say, 20 simulations of this total cost, where ideally what it should do is it should generate 10 random values for these 10 components for each simulation and calculate the total cost for that simulation. So essentially, it should generate 20 tables like these internally and should give us 20 total cost values. Think of it as simulating for 20 months. And then based on the 20 total cost values, we can perhaps answer certain important questions. So I'll say here, create another table showing 20 simulations of the total cost. Create, let's see what it does first, and then if it doesn't do what we expect it to do, sometimes, Claude, I've seen, comes up with shortcuts. Sometimes it does things where it's strictly not simulation, where, for example, instead of generating random values for these 10 components individually for each simulation, it might generate just one for all the 10 components, one same value, and then simply multiply by 10. We don't want that. That's not simulation, strictly speaking. So let's give it a chance to see what it does, and then accordingly we will ask it to correct itself if needed. Sometimes, depending on the number of people using Claude at the same time, it can be a little bit slower, but it's getting better. Yeah, there you go. We have 20 simulations of the total cost. Let's see if it did what it's supposed to do. And I can see that by clicking on the total cost for one of the simulations, and it did what it's supposed to do, where it randomly generated values between 1000 and 2000 for each component, and then added the 10 random values to give us the total cost for that simulation. So it did it same thing it did for each of the simulations, random numbers it generated and calculated the total cost. That's good simulation. That's the way to do it. But sometimes, like I said, in the past, I've seen it looks for shortcuts. So let's say, based on these numbers that we have, correct? So even these numbers, they're not all one, there are 20 of them now. So we want to talk about the total cost, the chance of the cost not exceeding a certain number. So I see some 14,000s, I see some 13,000s, 15 and 16 as well. So I'm going to ask it to calculate the probability that the total cost is less than or equal to, let's say, $14,000. And I'll also say based on these simulations. I don't want it to assume something and give me a value just like that. So the way we enter the prompt is also very important. Uh, Maybe we don't want to exceed $14,000. So we're trying to see what's the chance of being within $14,000. And if that number gives us a value, based on that, we can talk about the risk involved. So essentially, what it did is, in these 20 total cost values, it counted the number of values which are within $14,000 and divided by the number of values. So it also is showing us the function it used, so we can understand the concepts as well, thanks to these formulas. So among these 20 values, we have basically a few that are within less than or equal to 14,000. So, and notice that it changed, when I hit enter, all these values changed, all these random values within each cell, and then the total costs also changed. And if I press F9 again, these numbers will change, which means I don't have much confidence in these numbers. So the chance that total cost is within $14,000 for a certain month, or will be within $14,000 within for a certain month, is 10%. So risk is 90%. But if I keep pressing it, now I can say risk is 80%. 80% chance that the total cost will exceed $14,000. So if these are changing quite a lot, one way to fix this would be to increase the number of simulations. Instead of 20 simulations, maybe go with 100 simulations or 1,000 simulations. And if you press F9, in that case, if the numbers are not changing that much, then you are more confident about whatever you're talking about. In this case, the probability here. Correct? So increase the number of simulations. But how many is an ideal number of simulations? Should it be 1,000? Should it be 1,000,000? There's no way to answer that. In real life, there could be a lot of variables that keep changing randomly, or they follow certain distribution. And maybe there is something of interest. And you have seen in the past that unless you increase the number of simulations to, let's say, 1,000,000, you won't be able to have values which don't change that much. In this case, the probability here. And if you go with, let's say, 1,000,000 simulations, you may have to come back the next day to see the results, because it might take a long time for whatever software you're using to produce the results. With AI, maybe it's quicker these days, but it still does take time if you increase the number of simulations, given the large number of values you might have in your sheet. I hope that was useful to learn how to use Claude AI within Excel to perform Monte Carlo simulation. See you in the next video.